All right, are we on? All right, we're on. How's that? Am I on? Am I in the whole thing?
Yeah.
Am I all right?
Yes.
Okay, I got my videographers imported from around the world, from Singapore, Libya, and Bangladesh. Ooh, international group of videographers. Okay, so what do we want to do? We want to kind of summarize what we've been doing with electricity. Math test, Unit 2 is on November 26th. Science test is on December 14th, right?
Yeah.
So what we're going to do is we're going to look at electricity. Okay? We're going to look at electricity. Now, we talked about electricity, and we talked about two types of electricity. We talked about static electricity, and we talked about current electricity. And what we want to do is we want to summarize what we know so far. Okay? All right? We're going to summarize what we know so far. Okay. Now, let's put some words down. I'll fill the board with words. So, vocabulary words, okay? Like, first word, electron, correct? Where does the word electron come from?
Electricity.
No, electron.
Electronic.
No. Amber. It's a Greek word for amber, remember?
Yeah.
Yeah, a Greek word for amber. Okay? So, amber's a good word. What else? What else? Static electricity. What else? Positive charge.
Negative charge. Atom.
Negative charge.
Atom.
I like that. I like that a lot. Atoms.
Proton. Neutron.
Protons. Neutrons is good. How do you spell neutrons?
N-E-W.
N-E-W?
N-E-U.
N-E-U.
T-R-O.
T-R. If I could write on the board, I might not be teaching. I'd be so wonderful. Neutrons. What else?
Nucleus.
Nucleus. What else? Insulator.
Explosive.
Conductor. What else?
And
What else? What else? Insulator.
charge.
Conductor.
Charge.
Well,
Lightning.
charge. Didn't we do that? Negative charge.
Lightning.
This is negative charge. That word is charge, not change. You would never know it, right? The way I write on the board is terrible. Negative charge, positive charge. What else? Anything? Shall we wait? We'll add to it, right?
Yeah.
Okay, good. Now, let's say we have an insulator. What is the definition of an insulator? An insulator is what? Something that doesn't conduct charge. Okay? Something that doesn't conduct charge. Right. So, a charge can build up on an insulator, don't get me wrong, but nothing will happen. It won't flow anywhere. Correct? Yes? Now, a charge can also, this is really confusing. Now this is an insulator, right? Let's say this is a conductor, okay? This is a conductor. Now, in a conductor, you can have a charge build up as well, right? Can't you? Right?
Yeah.
Yes? But what's the difference? The difference between a charge building up on the insulator and a charge building up on the conductor. What's the difference? Well,
The conductor conducts electricity.
yeah. Let's hold off. Well, in other words, let's just hold off on that for a second, okay? Now, if I have like a toaster, okay, and where the electricity from the plug goes into the toaster, like say right here. Here's the toaster, okay, and here's the plug goes in here,
That's it.
right? Now, can't electrons build up there?
Yeah.
Yeah, they can, right? They can build up there, correct?
Static electricity.
They can build up there, right? Yes? Okay. Well, what happens is this. I'm not sure how I want to explain this, so I'm hedging a little bit. In a wire, let's do a cross section of a wire. Okay, that's a cross section of a wire. I have two wires that conduct the electricity to and from the toaster. Correct? Yes? Yeah. And because those electrons keep flowing, you're going to have a buildup of that negative charge. Is that reasonable? Is that reasonable? Okay. So if I touch that toaster, I could get a shock.
Yes.
Yes?
Yes.
Okay, now. So what they do is they put in a third wire. Okay? And this third wire will go into the plug. Yes? Now, in the plug, let's look at an American or Canadian plug. So in the plug, you have the box. Okay? And you have two plugs.
Sometimes three.
Yes?
Yes.
Well, yeah, I understand that, but let me get to that in a second. Now, behind the plug, that's this box. If you take that plug out and the box is empty, right? The box is empty. There's a wire that runs from here, the corner of the box, to a pipe in the wall. Right? Yes?
Yeah.
That runs to a pipe in the wall. And that pipe in the wall, if you follow it, goes into the ground. Okay? Now, this plug is called the ground. Correct? That plug is called the ground, that wire. And that collects these electrons that build up. And it goes in here, in this box, and you'll see a little third. That's where that plug goes. It's a three plug. If you look at it's three plugs that come out. I'm looking at the plug like this, right? I'm looking at it like this. I'm taking the plug and I'm looking at it. And the plug looks like this. I have two prongs and then a third one. This is an American Canadian, right? It could be anything. I'm just trying to make a point. Yes. What's wrong?
You're not really in the camera.
It's what?
You're not really in the camera.
Oh, I'm close enough. Am I in? He's my videographer. Am I in the camera?
Yeah.
Yeah, I'm good. So, yes.
You can take that as like a example.
Okay. You have it with you?
Yeah.
Let me see.
I got those. Don't expect me to have.
Okay, don't. Yeah, I got it. This isn't what I'm talking about. All right, but like this is the prong. This is American, and other places around the world. Is that on the camera?
Yeah.
Is it? This is probably something similar. I don't know really a lot about this plug, but it's probably your ground. Yes, that third plug is probably the ground. Yes, this is more Middle Eastern. I mean, it's places all around the world. So is this, but Predominantly Middle Eastern, predominantly North American. Yes? Okay. So, thank you. Thank you. So, this has a wire that goes to the toaster, right? That goes in through the wire and goes into the toaster and is hooked up on the side of the box that the plug goes in. So I take this plug and I put it in that box. And in the back of the box, it's wired so that third prong is wired to a ground, right? I'll give you another example. Lightning rods. Benjamin Franklin, to my knowledge, invented lightning rods. And we saw a picture of a lightning rod the day before yesterday, didn't we?
Yeah.
Well, the lightning rod is on a house. When I was growing up, I remember we had lightning rods on our house. And here's the house, okay? And it's usually up here. And then there's a wire that runs off the house, okay? It's on a big antenna, okay? And then it runs here. And then into the ground, a big post runs into the ground, right? And this wire is attached here. And the electrons, if the lightning hits the house, it hits the antenna. We used to have aerials. We used to have aerials a long time ago, before we had cable or anything like that. We used to get them through antennas. That's how we got our television pictures. We only had like two in New York City area. We had 2, 4, 5, 7, 9, 11. And then when I was a teenager, early teen, then we got your age, more or less. We got channel 13, PBS, public television. So anyway, the lightning would hit here, and then the electrons, please try not to squeak, the electrons would go down into the ground. Same exact idea, yes? So it's a way of discharging that buildup of charge, correct? There's a way of discharging that charge, yes?
Yeah.
And what are you actually doing? You're doing what? In other words, we had the Van de Graaff generator we saw. Okay? And they put their hands on the Van de Graaff generator, right?
Yeah.
They put their hands on the Van de Graaff generator. And their hair stood on end,
Oh yeah.
right? Remember? And what happened? All they had to do is touch something metal. This board is probably not metal, but we'll pretend it is. If they touched the metal, then the hair would go down, right?
No.
Well, what were you doing? You were taking the electrons. Your body conducts electricity, doesn't it? But you can still get a charge build up on it, can't you? How can you get a charge build up on your body? Anybody? How can you get a charge built up on your body?
By
You-
electrons inside your body.
That's right. You electrically isolate it. Okay. So if I have this on, I have my hand on there. I have shoes with very thick, or I'm standing on like a plastic milk case for milk or something, the old milk things, you know. And I'm isolating my body electrically. And I put my hand on this, and my hair won't go on end because I have no hair, obviously, right? But yours would, and yours would get fluffy because it's short, but hers would go, right?
Go this short.
That's really short. So it's not as short as mine, but in order to discharge, that's another one. Electrically discharge. In order to, you would discharge it. And what are you actually doing? You are essentially doing what? You're kind of completing the circuit, aren't you?
Yeah.
Yes, you're kind of completing the circuit. Remember, That's what they said the other day. You're completing the circuit, correct? So let's look at that. All right, so that's another thing. Completing the circuit. You're completing the circuit. What else are we doing? All right, so if you have a wire, high intensity wire, 12,000 volts, let's say, okay, enormous number of amps, 2,000 amps, okay, you know, a tenth of an amp can kill you, okay, so, and you're hanging from a pole, okay, here's your head, okay, here's your coming down stick figure, okay, okay, here's the poles, and here's the ground down here, and you're hanging from this wire. Are you dead? Why not?
Yep, you're good.
Are you dead?
No,
Why aren't you dead?
because you're not touching the ground.
Yeah, there's no place for the electricity to go.
You're not completing.
Yeah, that's right. You're not completing the circuit. If all of a sudden I bring the ground up, what's going to happen? The electricity is going to flow out of my body. Now I'm going to get a flow. Okay, so I'm going to complete the circuit. And the electrons are going to flow out my feet. Yes?
Yeah.
So in a way, insulators and conductors could be similar, couldn't they? I mean, you can have a conductor where electricity is not flowing, couldn't you? Let me show you what the main difference is between a conductor and a insulator. Let's say I have 3 layers. Okay? Let's say I have 3 layers. Okay? This is a conductor. Let's just use the letter C. This is a conductor. This is a conductor. And this is an insulator. Right? Can electricity cross between the plates? Can it? This is a conductor, this is an insulator, and this is a conductor. Can electricity go across? No, it can't. It can't. Because, why? Because electricity can't flow through a conductor, but through an insulator. Name me some insulators. Just throw them out. Plastic. What else? Come on, guys.
Humans?
What is it? Humans?
Humans.
Schumann?
Rubber?
Schumann's?
Rubber?
I like that. Very good. Rubber?
Metal?
Metal is an insulator? I wouldn't test that. Wood? Those are the main ones. Those are the big guys.
Glass?
Is air an insulator?
Yeah.
Yeah. Air can be an insulator.
Glass?
Glass could be an insulator.
Paper?
Well, that's kind of like wood, right? We'll say paper. What's a big one?
Mohammed?
Mohammed? No. Ceramic can be an insulator. Ceramics could be an insulator, depending on what's in this insulator. Okay, not all ceramics are going to be insulators. It depends on what ingredients are in the insulators, or in the ceramics, right? What else? Like glass is sort of like, is kind of a ceramic, right? Yes?
Concrete.
Concrete. Yeah, concrete might work. Concrete. I'm terrible at writing on the board. I've only become worse. Is that all right? Can you see that? What else? That's good, right? Okay. So it's not going to flow through. It's not going to flow through from the 2 conductors, is it? So what's the main conductor? Oh, could water be an insulator?
Water, yeah.
Yeah.
Yeah, water can be an insulator. Why? Does water conduct electricity?
Yeah.
No, it doesn't. No. What's in water will conduct electricity, but does water conduct electricity? The answer is no, it does not. Water does not conduct electricity. Understood? Okay. So could water be a conductor?
No.
Could, yeah, well, if you dissolve salt in it, okay, ions in water,
What are ions?
that,
Iron.
all right, let me explain what ions are. Let me just tell you, what's the main conductor? When you think of a conductor, what's the main thing you think of? Two things I think of. I think of the ground.
And metal.
Very good, metal.
Thinks about
What
metal.
happens is this. I don't know if I want to get into the chemistry here, but like, let's say sodium.
Chloride.
Sodium chloride is table salt. Sodium has a +1 charge and chlorine has a -1 charge.
Yeah.
You can dissolve it in water. Anything you dissolve in water is actually an ion.
Like salt?
Sugar. Salt.
Well, sugar's an exception, but sugar does it because of hydrogen bonding.
Salt.
But, well, yeah, salt. Well, salt.
Salting.
Salt is simply mean. So, things are charged. I don't want to get into the fact why things are charged or how things are charged because of the age of the class. However, things like sodium chloride are charged. When something dissolves, it generally dissolves because it is an ion. Salts are classes of compounds that form ions. That's not altogether true. Usually it's a metal from the left side of the periodic table with a non-metal from the right side of the periodic table, more or less. Understood?
Yes.
All right. So we have positive and negative charge materials that can be ions. Ions can be negatively and positively charged. All right. Now we know that electrons are negatively charged, and that's generally what flows in a current. Understood? Now you can also have things that are positively charged where you take the electron off. Let's say I have, let's look at sodium. Okay, sodium. 11 protons plus 11 electrons, okay? A proton is positively charged. Is that okay? Do you understand that? Did you know that?
No.
Okay. In the nucleus, you ever heard of a nucleus?
Yeah.
Okay, in the nucleus there are 11 protons for sodium. Yes or no? Make sense? Okay. Each proton has a positive charge. Easy? Okay. Each electron has a negative charge. Okay? So if I have 11 protons and 11 electrons, it's going to have a neutral charge, correct? Yes or no? Now, if you look at a periodic table, this is going to get a little confusing. If you look at a periodic table, sodium has an atomic number of 11, the number of protons, right? One less than 11 is 10. The element with 10 protons, or an atomic number of 10, is neon. Yes? Neon, that's an element on the periodic table. Now, neon is very special. It's inert, it doesn't react. Yes? There's something about the structure of neon that makes it inert. If an element has 10 electrons, it's going to look electronically like neon. Is that okay? Okay. therefore it'll be inert. Everything reacts to be inert. Things don't chemically react because they want to react. They react to become stable. They react to become inert. Yes? So, sodium wants to get rid of one electron. It can't get rid of the protons, it can only get rid of electrons. So if it gets rid of one electron, how many positive charges does it have? It has 11 positive charges and 10 negative charges. Right? So what's its charge going to be? +1. That's right. Very good. It's going to be +1. Very good. Okay? Well, chlorine has 17 protons. It's right next to number 18, and 18 is a noble gas as well. It's argon. Very stable. So if chlorine gains an electron to be like argon, it's going to have one extra electron, or a -1 charge. Where is it going to get it? Well, it's going to get it from sodium. Give and take. Kind of cool, yeah? Easy? Yes? So that's how atoms get charges, because they want to be like noble gases. Okay, are you all right with that?
Yeah.
So, you can have the ground, you can have metals, you can have ions in water. These are all conductors. Understood? Those are all conductors. Now, conductors will allow electrons to flow through them. Conductors allow electrons to flow through them. Yes? What does that mean? That means that if I have a circuit, and I'm going to put a battery in the circuit, okay? This is DC, and I put a light bulb here, right? I put a light bulb in that circuit. If I close the circuit, here I have a switch, and I close the circuit. When that circuit is closed, that light bulb will light, because electrons are passing through the light bulb. Yes? And it's allowing it to operate. Yes? Now, let's look at how a light bulb works. When you think of a light bulb in an electric circuit, you think of an incandescent, little tiny incandescent light bulb, correct? Incandescent. Okay?
We have these light bulbs, these wires, and these batteries.
Yeah, we're gonna do a lot of experimenting the next time we meet. We're gonna do, this is all online. We wanted to memorialize this. We wanted to get it on tape. So this is your reference material, understood? And then we can work in the lab and have some fun. Okay. So, what is it? Yes.
We have 3 minutes left.
We have 3 minutes left. That's it. Oh my goodness. How did you know there were only 3 minutes? Oh, you're thinking. Okay, good.
See the time?
All right, let's do this, okay? You ready? Did you ever, you guys are too young to remember, but light bulbs, maybe you still know it. Do you have incandescent light bulbs at home? Do you have light bulbs at home that get really, 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 very, 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 really, 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 very, 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 very hot?
Yeah.
Yeah.
I've
Okay.
seen some. Yeah, I did. I literally not. I take it
And
out.
they'll burn you? I mean, they're so hot.
Yeah, I'm like,
Okay,
ooh.
those are called incandescent light bulbs.
Yeah, everywhere in my house. Like,
Incandescent.
it's not open.
Incandescent light bulbs. And they get so hot, they're 95% inefficient
That's why they burst up.
for light as a light source, but 95% efficient for heat, as a heat source. They're very efficient as a heat source, but not as a light source. What happens is electrons are forced through the filament, and the filament, the electrons back up, and it gets very hot. It gets so hot, it's white hot. It gets white hot, and
Boom.
no, it just shines brightly, and you have light. Okay? Now those kind of lights are incandescent. Look up the word incandescent. How do you spell incandescent? The two words that I want you to look up are fluorescent. Right now, look up, sound it out. F-L-U-O. Fluorescent and incandescent. You sound it out. Try. You've got to learn how to spell these words.
Low battery.
Your phone.
Low
The
battery.
what? Low battery? Okay. It's all right. It's still taping.
What's the word?
Incandescent
And
and fluorescent. I'll start you off. Fluorescent. Now, when you have infrared, which is heat, infrared to visible, and then you have ultraviolet to visible. That's fluorescent. Yes? So look up, how do you spell incandescent?
It's time to go.
I understand that, but we're going to stay here and finish this because we have math class anyway. Okay? So stop looking at the clock.
That's
I understand that. Now, stop looking at the clock and find out how to spell the words. Go ahead. You got it?
I got fluorescent.
How do you spell fluorescent?
F-L-O-R-E-S-N-T.
F-L-U-O-R.
All right. All right. We'll pick this up the next day. Okay? You've got to learn how to spell fluorescent and incandescent. Understood?
Okay. So
Now we'll have math. Understood? You have it?
yeah.
How do you spell it?
I-N-C-A-N-D-E-S-C-E-N-T.
Good. Write that down. Incandescent.
It's on tape.
Any idea how to spell fluorescent?
Yeah, F-L-O.
I don't think that's right. Are you sounding it out or are you actually looking it up?
Yeah, I didn't look it up.
Well,
Give me my computer.
F-L-A.
no.
Brown pencil.
Come on, I looked it up.
Here, did you look it up?
Is it an autocorrect? Yeah. Fluorescent.
Go ahead.
F-L-U-O-R-E-S.
R-E-S.
Yeah, C-E-N-T.
R-E-S.
C-E-E-N.
C-E-N-T.
All right. This is fluorescence. Fluorescence.
Yeah, that's C-E-N-T.
Okay? Fluorescence and incandescence. Fluorescence is going from UV to visible light. And incandescence is going from infrared to visible light. How do you spell the end of fluorescence, though? Is it C-E or is it S-E?
C.
Okay, you guys got to learn how to spell, man.
Come on, it's just showing my computer.
Oh, no, my
Responded
goodness.
so fast.
Okay, all right, guys, we'll meet in math class.